Good morning, everyone. In the last session, we discussed about the method overriding concepts here. So today we are going to discuss about the one of the another important concept called abstract classes here. Okay. So far we did not discuss about the abstract classes, and here what exactly the abstract classes will do. So there are some situations here which we are going to provide the superclass and then declare the structure of the abstraction. So basically, so what are the common properties we are going to use in our subclasses here? Those information we are going to make under the abstract classes here. Okay, and the particular method we are going to override into the subclasses here. Basically, what happening here? Whenever I'm trying to declare here, let's say inheritance A class. Here I'm defining show method, and again the same show method I'm trying to define under this particular inheritance B. So whenever the same show method I'm trying to define into the subclasses here, what happening internally? The superclass method is hiding here. Getting the point? The particular superclass method is hiding here. So here using this particular abstract classes, now what we will do? We are going to provide the we are going to provide the structure of the abstraction. It's like the common properties we are going to provide in the abstraction classes, and so whenever it is required, we are going to override the specific methods here. Okay, and when you call the specific method, every time it will call the subclass methods only, not the superclass, because in the superclass we don't have a body here, just we are going to declare the method. But how we are going to declare? So using this particular abstract classes here. Okay, so this is very important, we need to understand here. So why we are going to make abstract classes? Because it's not fully implemented, the particular class. Whenever the particular class is not fully implemented, we are going to make the particular class as a abstract here. Okay, so this is very important, we need to understand. So let's write a simple example here. So I'm defining abstract A. Okay, so this particular abstract A class, now if you observe how it is going to write here. I'm defining call me method. If you observe carefully, this method, it does not contain the body. Getting the point? This method does not contain the body. So just we are declaring this particular method. Getting the point? Just we are declaring this particular method. So if it is a method body, how we are going to write? So this is the way we'll try to define the method body. Like here we are going to write this is the braces, and here we are going to close the braces. Here we'll open and we'll close. This will contain the method body. But right now what I'm doing here, I'm just declaring the method. I'm not defining the method body. So whenever I'm trying to declare this particular method, now this method is not fully implemented. Getting the point? This method is not fully implemented. So if the method is not fully implemented, now what we can do? The method, so we need to share the information to the compiler. So how the compiler will understand here? So this method is not fully implemented. How this is going to understand? So using this particular keyword, compiler will understand here. Abstract void call me. So why I'm making this particular abstract keyword here? Basically, this method is not yet implemented. So just we are declaring this particular method. Whenever any class is going to extended by this particular abstract class A, so this method is going to override there. Okay, so there if you override this particular method, what happens internally? It will try to come up with the method body. Getting the point? So this is we need to understand very carefully. And whenever I'm making the method as an abstract, so the class is not fully implemented. Getting the point? So here we need to understand whatever the class we are declaring, the particular class also is not fully implemented. The particular class also we need to make abstract here. So if you observe carefully, now whatever the error we are getting, all the errors are resolved here. Why this particular errors we are getting? Because if this particular method is not implemented, now what we are doing here, we are making this particular method as a abstract. Once we make this particular method as abstract, the method does not contain the method body. So just it's going to declare, okay? And if any one of the method is available, any one method is available in our particular class as a abstract, so the particular class we need to make as abstract here. Why we need to make a class as abstract? Because this particular class is not fully implemented. It is implemented partially. So how it is implemented partially? If we observe here, what I'm doing here, yeah, I'm going to come up with a one more method, something like call me to. Okay, this call me to is contain the method body. Okay, this call me to contain the method body. But what about the call me method? It does not contain the method body here. So that's the reason I'm making method as a abstract. Once we make method as a abstract, we should make class also abstract here. Okay, so these are all the important information we need to understand. And so this message, this is one of the concrete methods. Getting the point. This is important. Okay, now we understand here, because we one method is not yet implemented, we made as an abstract, and the particular class also we are making as an abstract. And once we make this particular class also abstract here, so what is the best way here? We need to extend this particular class. We need to extend this particular class. Okay, how I am extending? Observe, for just for understanding, I'm creating one more class here, and this particular class I'm making as a abstract B. Okay, but it is not the abstract class here, it is a concrete class. And only abstract here. Whenever I'm making the inheritance relationship here, observe here, the abstract B is getting an error. So if you observe carefully, if I'm trying to remove this relation, this class will not get any error. This particular class will not get any error. But whenever I'm trying to add this extends related information, observe carefully, we are getting an error. Why we are getting an error? Okay. Why we are getting? If you observe the error, so add unimplement method or make this particular class also abstract here. Basically, what I suggested earlier, whenever we are making any class with this extends relationship here, what happens internally? Whatever the superclass functionality we will have, all the superclass functionality will available logically into this particular subclass here. Getting the point? So this is important here. Now either what we can do, so here we can make this particular, either we can make this particular class abstract or we can implement the abstract method. So what is the abstract method we are having here? The call me method we made as a abstract. So if I'm going to click on this and implement method, observe carefully. Now the abstract B class contain the call me method and it's now contain the method body here. Okay. So this is very important, we need to understand here. Getting the point? So this is very important, we need to understand here. Okay, so now what I'm doing here, I'm extending with the abstract class, and this is the concrete class we define here, and this particular concrete class contain the override method called call me, and the same method what we did in the abstract here, we come up with a method declaration. Now what you understand here? So if you create an object here, if you create an object either abstract B, now which method is going to call right now? This particular abstract B class call me method will call me method only it's going to call. So why the call me method is going to call? Because in the abstract class A, the method does not contain the method body. Just we declare here. Getting the point? And now if you observe carefully, the superclass method is hiding here. No, the superclass method is not hiding here because the superclass method does not contain the method body. The superclass method, it is not fully implemented here. Okay, just we declare the method. So if you observe carefully, abstract class is nothing but, so it is the opposite way of the method overriding concept here. Getting the point? It is the opposite way of the method overriding concept. Method overriding concept basically, so if you define the method in the superclass, if the same method, if you are trying to override into the subclasses here, the superclass method is going to hide here. Getting the point? The superclass method is going to hide. So to eliminate the method hiding concept here, now what we are doing here, we come up with just declaring the method. Here we are not using the method body. So just we are declaring, right? And now abstract A is a superclass for this particular abstract B. Abstract A is a superclass for this particular abstract B, and I'm overriding this particular method. And whenever I'm trying to create a object of this particular abstract B, every time it will call this particular call me. And other than this particular call me, we don't have another method here. Okay, so only one method we are having with the method body. Okay, this is important here. And the simple message I want to write here. And so this particular B class implementation of this particular call me method. Okay, so this is the way we can write the information. Now again, I'm going to come up with the same example, inheritance main, but here what I will do, I will comment out this particular example section, and here I'm creating an object here. Abstract A and is equals to abstract B. Okay, and now so if you observe carefully, which object I'm creating here? Abstract B object I'm creating. And what is the type I'm making here? Abstract A. Can we use this particular type here? Is it possible to use this particular type called abstract A?
No, sir, because it doesn't have any definition for that.
So you can see here, we are making the relation right here.
Yeah.
So why can't we use here? So this is I explained earlier. Superclass reference can be accessed the subclass information. And one more example, the dynamic method dispatch. So these two examples we discussed in the previous example. Okay, so anyway, subclass object we are creating here, but we can make a superclass reference here. But the problem here, only the common functionality only we can access. For example, in the abstract B. So if I'm going to write the method, something like a void, B test method. Okay, and here abstract B. So this is basically, this is the abstract class B specific method here. And now, so if you observe carefully, whenever I'm trying to call this ABA dot, B test method. Now you can see, so I'm getting an error. Why I'm getting an error? So even if you see, the B test method is already available inside this particular abstract B class. But we are unable to call this particular method here. We are unable to call this particular method. Why we are unable to call? Because it is a specific method which we declare inside this particular abstract B. This is the specific method which we declare under this particular abstract B class. But if you observe carefully, so instead of this particular section, now I'm going to run one more method, something like call me. So observe carefully. Now this method is not giving any error. Why this method is not giving me any error here? So why the above one is giving me an error? Basically, so this is the yesterday we discussed here. At the compile time, what happens here? This method is going to identify. At the compile time, this method is going to identify. So what is the reference? What is the reference we are using? ABA. ABA is a what type here? It is a abstract A. Now it will go to the abstract A class and it will identify at compile time whether this call me method is available or not. Whether this particular call me method is available or not. So if you observe carefully, if I'm going to comment out this section code, you can see what happened here. It's giving me an error. Why it is giving me an error? At compile time, our compiler, it will try to identify in the type called abstract A. Right now, we don't have a method inside the abstract A class. Getting the point? So I commented this particular section of code. Getting the point? This is important here. Whenever I commented here, it's giving me a compilation error. It's giving me a compilation error. Now you can see the error is resolved. But at runtime, this is important. At runtime, this method is going to call the subclass. At runtime, the method is going to call this particular abstract B. If the abstract B does not contain the call me method, it will look up the superclass. So this is very important, we need to understand here. Okay, compile time, it will look up the superclass method. Runtime, it will look up the subclass. Why it is look up the subclass here? Because what is an object we are creating here? Abstract B. Abstract B is a subclass of abstract A. Because of that only, it will look up the subclass. So now if I'm going to run, now you can see, so this is the B class implementation call me method. Now where we define this particular message? Inside the abstract B here. You can see inside the abstract B, we provided the message here. Getting the point? So this is important information we need to understand here. Okay. So any questions regarding this particular superclass reference with a subclass object here?
Sir, what's this concrete class?
See, the difference between abstract class and concrete class, abstract class basically here, it is not fully implemented. So it is a partially implemented. So this particular classes we'll call it as a abstract classes here. And the concrete class basically, it's contain the all implementation here. It is implemented fully. If you see, observe, abstract B, it is fully implemented. So abstract B does not contain any method without the method body. But here in our abstract class here, we have one method. Okay, and in this section, what we need to understand, so this particular call me method here, it is hiding. So whatever the method overriding concept we discussed in the last session, so when we are trying to override the same method in the subclass, the superclass methods are overriding. But here, if we observe carefully, so whatever the method we are overriding into the subclass here, the superclass method is hiding. No, the superclass method is not hiding. Why it is not hiding? Because it is not implemented. So just we declare the method here. Okay, getting the point. So just we declare the method here, but we did not implemented the method. Where we implemented the method? We implemented method under the subclass here. Okay, so this is the purpose of the abstract classes we are going to use. And here, what we need to understand, once we make a method as an abstract, we should come up with a class also abstract. Why we need to make the class also abstract here? Here, because this particular class, it's not fully implemented. It is partially implemented. Okay, so this is the purpose of this particular abstract classes here.
So, sir, in abstract class, we can't implement any method. All methods should be only declare.
No, you can see that's the reason I come up with one more method here. Call me to. The call me to is not an abstract method.
Abstract method. Sorry, sir. So in abstract
So
method.
This, okay.
Yeah, just my question is like if the class is abstract, so
Okay.
all the if we have lots of method, So all the abstract methods should be only we should declare them. We can't implement them.
See, basically what I'm doing here, at right now I don't have an implementation of this particular call me method, but I am having some implementation of this particular call me too. I can implement this, but whatever the method we don't have right now, we can make those methods as a abstract here. But here we have a option. If you are interested to override this particular method, nothing will happen. You can write with something like method body. Okay,
So we
you
can,
can
yeah. Okay, got it. Just my question was is this only just can we implement the abstract method?
see abstract method. If you are implementing this particular method here, you need to remove the abstract. Basically, abstract is nothing but the method is not yet implemented at this point. Karinba, the keyword itself is saying the information. The method does not contain the method body. If you remove the abstract, definitely we are going to write with the method body only. Say, for example, you are not writing the abstract here. So just you are declaring like this, but it's giving me an error. Why it is giving me an error? So basically here it's giving the two suggestions. Add the method body or you can change to the abstract here.
Got it.
Okay, so any other questions?
No, sir.
No, sir, in the abstract B class, why we are writing at the rate override, sir? Because we are giving the definition of the abstract method in this class. It's not a override, right, sir?
So it's override only, right? Basically, the method is not basically this method is not specific to the abstract class. Whatever the abstract B class we declare here, it is not specific to this. This method is coming from the superclass. The superclass method we are overriding here. So even though the method is not the method does not contain the method body in the superclass, but the method is coming from the superclass only.
So in that perspective, we are telling it as override, is it?
Yes.
Okay, okay, sir, got it.
And here, so one more information, if you observe carefully, this particular abstract here, if I'm going to make superclass reference here, so as we discussed here, we cannot call this particular B test. B test is the method. This is the specific method we define under the abstract B class. Now what we can do? So in that case, directly we can come up with the abstract B. And once we specify the same type here, now observe, we are able to call the specific method which are available under the abstract B. Right? So this is important here. But when we can go for this particular superclass reference and when we can create the subclass object, this is important here. Getting the point. So basically, this abstract class contain any specific information. So in that case, we cannot define the superclass type here. We can define the subclass type here. But whenever we are trying to come up with the common functionality, like what we override inside this particular abstract B, because these are all the common methods. Even though one method is an abstract, one method is the normal concrete method. Now these two methods we can access into this particular abstract B, and if we want to access only the common functionality, now what we can do? We can go for the superclass reference. Here we can make the superclass reference, but most of the cases, so make the subclass reference and we can access the superclass information along with the subclasses information. So now if you observe carefully here, ABA dot call me to method, but this particular call me to method is not defined inside this particular abstract B class. Getting the point? So this particular method is defined in our superclass here. But even though we are able to access in our subclass here. Getting the point? So this is very important here. But only if we want to access the common functionality only, we can go for the superclass reference. But other than this, we can make every time subclass of object references here. Okay, it will available if the method is available inside this particular abstract B, it will call. Otherwise, it will look up the superclass methods here. Okay, so this is important example we are discussing about the abstract classes here. So any questions regarding this particular abstract classes? Okay, so I'm going to declare, like I'm going to come up with one more example. It's like a one of the real-time related example how we are going to declare this particular abstract related information. So if we observe, so this is the figure class I'm trying to declare here, and this particular figure class will contain here. So I'm not making this variable as a double, or we can make here. So private I'm making double dimension 1, and here dimension 2. Okay, so these are all the two variable I'm having here, and I'm trying to come up with one constructor here. So I'm defining the constructor double a comma double b, dimension 1 is equals to a, dimension 2 is equals to b. Okay, so this is the constructor I'm defining, and what I'm doing is I'm trying to define one method. So this is the double method I'm declaring here, and I want to make this particular method as a abstract. So now what you understand here, the area method I'm making as an abstract. Why I'm making this method as an abstract? Because this method we are going to override into so multiple subclasses. Okay, so this is the common method we are going to override whenever this any class is going to extend this particular figure class. Okay, now what I want to do here, the class also we want to make as a abstract here. Okay, we made this particular class as an abstract here, and finally I want to generate this particular setters and getters. Setters is not required, only getters. Okay, so this is the one abstract class we defined here, and so we define the encapsulation principles here. Okay, directly we are not able to access this particular variable, so we are going to access the variable through this particular method section here. Okay, these two methods are returning double type here, and whatever the method we are going to override, the particular area method also will return some double data type value here. And now, so we define the one abstract class, and what I'm going to write here, I'm going to extend this particular abstract class with another class, and here rectangle I'm going to define. So this rectangle, it will try to extend from the figure class here. Okay, the rectangle class, and is going to extend with the figure. So once it is extended, so we already identified either this rectangle class also it's expecting to implement the whatever the abstract method we are having. Otherwise, if you are not interested to implement the particular method, now what we can do, we can make this particular class also abstract here. So whenever we are making this particular class also abstract here, again what happens here, again the compiler will understand this particular rectangle class also it is not fully implemented here. So now you can see, basically we are getting a first error. That is because in the figure class, if you see, we did not define the default constructor. Whatever the constructor we define, it is a parameterized constructor. So I explained earlier, whenever we are defining the parameterized constructor, we should define the default constructor. Otherwise, now what we can do, whenever we are extending to any other class, the other classes like the subclasses cannot define the default constructor by default. Compiler cannot define the default constructor by default because in the superclass we are having parameterized constructor. This is also very important here. Okay, in the superclass if you are not defining any constructor, so same thing you cannot define any constructor in the subclass. But once you define the any constructor in the superclass, first you need to define the same constructor here. Otherwise, we'll get an error here. Why? Because compiler cannot call the default constructor here, because explicitly we are defining the constructor. The same constructor we should define inside the subclass here. Okay, let me define the constructor first here. Now you can see I'm defining the rectangle constructor. Getting the point? Is expecting the two parameters. I'm calling the superclass constructor. That is fine. But still, now if you observe, still we are getting an error. Again, why we are getting an error here? So if you read this particular error one more time, this particular class is giving the two suggestions here. So either you can make this particular rectangle class as an abstract, or you can unimplement this particular method. What is the method we need to unimplement it? That is called area. Okay. So now what I'm doing here, I'm going to make this particular class as an abstract. So now we can see whenever I'm making this particular class as an abstract, now what you need to understand, the rectangle class also, it is not fully implemented here. Why it is not implemented? Because we already in the figure class, we have a one method that we made as an abstract. The method we should override into this particular rectangle class. But at this time, we are not interested to override. Now what we are doing is, again, we are making this particular class also an abstract. Getting the point? So this is important. But here, what we will do, I'm going to remove the abstract keyword here. We'll implement the particular method here. Okay. So the area method I'm implementing. But what we need to understand here, I'm going to return the area by multiplying this particular dimension here. Now I'm going to call the get dimension 1, get dimension 2. So based on this particular dimension value, I'm going to return the area of this particular rectangle class here. Okay. So this is the one example. So here we are implementing the area method, and one more class I'm going to create here. So this is basically triangle class. So one is the rectangle class we are creating, and another one is a triangle class. And if we observe, this particular triangle also is extending from the which class? Which class is going to extend here? This is again extend from the figure here. Okay. So now observe, first I'm adding the constructor, and later, now what I will do, again I'm going to provide this particular area method. And here, so get dimension 1 and get dimension 2. So I'm going to divided by this particular 2. Okay. So this is the triangle area I'm trying to find out here. And finally, so what is the hierarchy we are using here? What is an hierarchy we are using here? So the hierarchy, if you observe carefully, one superclass, two subclasses here. Getting the pen? But here, inside the two subclasses here, what are all the common functionality we are using? That is called area. But inside the superclass, we are not declaring we are not having the method body of the particular area. If any class is interested to come up with the implementation, now what we are doing is, we are going to extend this particular class, and we are implementing the specific method under the subclass here. Getting the point? This is important here. Just we are declaring the method in the superclass. If it is required, if you are interested to override the method, or if you are interested to implement the method, now what we are doing is, we are making the relation with the superclass with the subclass, and we are overriding the specific method area, and we are coming with the specific implementation. If you see, so this value will return something, and whatever the triangle we are the rectangle we define here, so this is return something here. Okay. The output is different here. Now what you understand here, it's like a specific implementation. It's not the common implementation here. Okay. Now what you understand here, whenever we want to implement the specific implementation, so those method we can make as a abstract here, so that if the abstract class is extended by any other class here, we are going to override the method, and we'll come up with the specific implementation here. Getting the point? So this is very important, we need to understand here. Okay. Now, so this we understand carefully, and finally we are trying to understand the inheritance related one of the this particular inheritance example. And finally, what I will do, I'm going to create an object. So how we can create an object? So here I'm going to create an object here. Let me comment out this section. Okay. Here figure f is equals to, can I create an object of this particular abstract class here? So I just want to confirm here. Can I create an object like this here? Something like a 25.
No, sir.
Why we can't create here?
It has an abstract class where the definition is not available, so we cannot create object for the abstract class.
Yes, if you observe carefully, this particular class is not fully implemented here. Now you can see, so even though we have a constructor, inside this particular figure class, if you see here, this is the constructor. Getting the point? So this is the constructor we are having right now. Now what I'm doing here? Even though we have a constructor, we are unable to create an object of this particular figure class here. Now you can see, cannot instantiate the type called figure here. So it's saying that we cannot create an object of this particular figure class here. Okay, what is the best way here? So we can go for the either rectangle or triangle. So this is the two classes we can create here. I'm creating the rectangle class, and the type also I'm going to make as the same. Okay, so this is an R I'm creating, and I'm going to create a triangle. T is equals to new. So triangle. Here I'm going to provide something like 96.52 and 87.65 because it is a double type. Okay. So now observe carefully. We created the two objects here. Triangle class and a rectangle class we created. So finally, what we will do, we'll call the methods here. What is the method we can call? Whatever the method we override here. So r dot area method. So this is the area of this particular rectangle, and one more method I'm calling here t dot area. So this is the triangle area. Now you can see first one is a rectangle we are calling, second one we are calling as a triangle. But what we need to focus here, this is we are already familiar calling the method after creating an object. But only what we need to understand how we are defining the common method in the superclass and how we are trying to override into the subclasses here. Okay, so this is important we need to understand here. Any questions? So this is the way only we are going to create the abstract classes, and we'll try to come up with the implementation classes in the real-time scenarios here. Okay, so you can imagine how we have defined the rectangle class and the triangle classes with the figure classes here. Okay, and yes, tell me.
So what is the purpose of this abstract class?
See, basically, if you understand the method overriding concept, you can easily understand this abstract here.
No, without abstract method, we can already simple method we can write and we can override in the next class.
Simple method how? If you observe carefully, where we define it. This is the simple method. Call me to. Okay. If I'm trying to write the same method in the subclass, this method we cannot call here. Getting the point. So this method, if I'm writing inside the abstract B, so for example, here, so I'm adding the abstract abstract B information here. So let me enable this. So you can see it is calling the abstract class B method, not the abstract class A here. Even though the same method is available here, here the concept it is hiding here. So no way to call this particular method from the subclass here. If you create an object of this particular abstract class here, then only you can call this particular method. But otherwise, we don't have an option to call this particular method. But using this abstract classes here, this method basically it is a abstract method. But here what we are doing is we are trying to override into the rectangle and triangle. And here if you go to here, so you can define the any type. Either you can come with a superclass type or you can come with a subclass type. We are able to call the area method. And here, whenever you are calling the area method, so the superclass method is not hiding it because inside the superclass, we did not define the method basically. Just we declare the method, the information we are overriding into the subclasses. Okay, and it is a common method. If you see, the same method we are overriding into the two classes. So here we are overriding, and this is the specific logic we are implementing here. And inside the triangle, we come with one more specific logic. If you see the output here, the output is different. Now what you understand here, the same method is reusable multiple times, even without hiding the method. But if we use the same method overriding concept here, even though we are going to use the same method in the different subclasses here, but here in the superclass method we are unable to call because the superclass method, even it is contained the method body, it is a dummy. So there is no use of the superclass method here. So to overcome the method overriding concept here, the abstract methods are introduced here.
Sir, I have one doubt.
Okay.
In the overriding concept, we are hiding the implementation, and in the abstract, even though the method is not defined, we are overwriting with our new definition. I didn't understand what is the opposite which is happening in the abstract, sir.
So only the important information basically which class we defined. I think this. Okay. So if you see inheritance here, we have a show method. Okay. And inheritance B, we have a show method. Okay. And now what I'm doing here, I'm going to create an object for inheritance A. Let me show you that example. I think somewhere we defined. Okay, if you observe carefully here, so inheritance A object we are creating. Whenever I'm trying to create this object here, if I'm going to call the same example, so which class method is calling here? Inside the inheritance A constructor and the I and j values are calling. Okay, but if you observe the same method, we already override into this particular inheritance B, and now you can see the relation we are having, getting the point, inheritance relation we are having here. And so whenever I'm trying to create an object of this particular inheritance B, if I'm going to modify here inheritance B, so something is expecting one more parameter. Okay, so this is the inheritance B. And if you observe carefully, even if you see here, this is the type inheritance A only. This is the type, it is a inheritance A. But here, which method is going to call? Here, which method is going to call here? Now you can see I and j and k values are printing here. Now, which method is calling a inheritance B method is calling, but the type we made as a inheritance. Why it is not calling the inheritance A method? Because the highest priority it will go to the subclass method. If the subclass method is not available, then only it will go to the superclass method. But what we are doing it for our specific implementation, we override the method into the inside this particular inheritance B class. Okay, every time it will take the highest priority this method. Even if you see here, the type if you change here, if you change to the inheritance B, So if I'm going to call one more time, the same method will execute here. Now you can see I and j and k values here. Getting the point. Now, what is the use of the inheritance a? What is the method called? Show method. What is the use here? This method is not yet calling here. Even if we specify the superclass type or if you specify the subclass type, this method is not calling. And every time it's going to call this particular method. Okay. So this is waste of defining this method. Getting the point?
So instead of writing the definition, as it is not using anywhere, so we are defining it as an abstract. Am I right? Sir?
Yes, yes. So this
then it is
method,
not called opposites. Am I right, sir? We just modified, instead of writing the definition, we declare it as abstract.
yeah, the same abstract method is going to override into the subclasses wherever it is required.
Okay, got it. So abstract class is kind of an index of a book. Am I right, sir?
Yes. So basically, we can understand here. So in whenever you're like implementing any application, so instead of specifying the method in the subclasses, so those method we can write as a abstract. For example, sum method or average method or minimum method or maximum method, we can write inside the one abstract classes and extend this particular abstract class, and you can go for the specific implementation here. So that this is the method only one place we are defining, and we are going to use reusable multiple locations here. So it's like this is an important. We define all the information here. We are going to reusable multiple locations here. Getting the point. So with this particular class, so this is our figure class, is going to extend multiple classes here.
Sir, is it kind of polymorphism, sir? Like we are using in a multiple ways.
See, that we discussed yesterday, like a runtime polymorphism. So that will understand the same concept here. Okay. Any other questions here?
Sir, I have a question. For the inheritance class B, if you had same parameters I and J, similar to class A.
Okay.
And then if you use the subclass object, so it will still go to the subclass method, right?
See, this subclass method is calling, but the problem, whenever we are calling the constructor here, what we did, super keyword we are using. So it will execute the super class and it will initialize the I and j values, and it will come back and it will initialize the k value. And the method here, it will take highest priority on the subclass method.
Okay, so what if we did not have k value here and we have like only ij in both the classes?
Nothing. So you can see here, see.
Okay.
So that is not related to the variables here. How many variables you want to take, you can take.
Okay. Okay. Thank you.
Okay. So now we'll move on to the final here. So we discuss about the final variables here. Basically, whenever we are defining the variable as a final, only one time we are going to initialize the value. So now here, what I will do, here I'm going to come up with one variable, something like here I'm making as 100. So whenever I'm making 100 here, now what I'm doing is, this particular value I'm making So if you see, it's giving me an error here. Why it is giving me an error? You can read this error. The final field value cannot be assigned here. Only one time only the final values we can modify here. So if you are trying to modify from the second time onwards, it will give you an error here. Okay. So this is important when we are making the final at variable level. The final keyword we are using at variable level. Getting the point? This is important here. Only one time we are going to modify this particular value. So once you modify here, if you are trying to modify line number 12. So if I am trying to remove this final, now you can see the whatever the error we are getting, the error is resolved here. And whenever I'm making this variable as a final, again we'll get an error. Again we'll get an error. Why? Because the purpose of this particular final variable, only one time it will modify. If you're trying to modify from the next time onward, it will give an error here. Okay, so this we understand about the final variable, and we'll move on to the final methods here. Getting the point? So final methods, and now how this particular final method will work here. I'm having so one more method I want to define, and here so I want to define as a final test method, and this particular final test method I'm writing here something like okay. So this is the figure class final test method, and I'm making method as a final. Okay, observe carefully. So this particular method, if I'm going to override into the subclass, I'm copying this method here. Okay, and I'm going to override into this particular rectangle class. I'm going to remove this final here, and now you can see even if I'm trying to remove the final also, it is giving me an error here. Why it is giving me an error? This is important here. Okay, now if you read this error message here, so the whatever the final test method we defined here, so we cannot override into the subclasses here. Getting the final variable, it will modify only one time, and the final methods here, it will not going to override into the any subclasses here. Getting the point? So using this particular final, we can make some restrictions here. If the method, if you're not interested to override into the any other subclasses here, what we can do? So just we can make method as a final. Okay, the final method is not going to override into the any subclasses here. So this is I want to share the information here. Okay, same thing here. If you make this particular method as a final here, whatever the show method we are writing here, so now you can see inheritance B, it is giving me an error. You can make the naming convention different. If you are interested, you can make something like show one. Okay, so this is the different method. But whatever the same method, if you are trying to override into the subclass, it will give an error. Why it is giving an error? Because the final modifier, it's not going to override into the any subclasses here. Okay, so this is just I want to share the information regarding this particular final. And one more, if we observe this class, here I am going to make final. If I'm going to make final at a class level, now you can see the inheritance B, it's giving me an error. So why it is giving me an error here? You can read this. The inheritance B cannot be subclass of this particular final class. Okay, the final classes, it's not going to support in our inheritance here. So the final classes cannot be extended here. Getting the point? So this is important here. We define the final information at 3 level, variable level, method level, as well as class level here. Okay, so any questions regarding this particular final?
Sir, can we declare final for abstract class also?
No.
No. Because it doesn't have any definition somewhere, we have to provide
Yes.
definition.
Basically, why we cannot? Because it is not fully implemented, this class. This class is partially implemented. This class should be extended some other class. It is a mandatory.
Yeah.
Getting the point? So this method should be override in the subclasses here. For that cases, we cannot go for the final. Because the final is going to prevent something. Like it's not going to give the option to extend some other classes here.
Yeah. Okay.
Okay. And now, so we need to understand the abstract class, object class. Basically, so if we observe carefully, so this is the inheritance A and this is the inheritance B. And inheritance B is extending inheritance A class. Inheritance B is extending inheritance B A. And here we are understanding inheritance B is a subclass and the subclass contains the superclass that is called inheritance A. And for this particular inheritance A, what is a superclass? Getting the point? What is a superclass here? So object is a object is we have one class and object is a superclass for all the classes here. Okay, and if you see for this inheritance we have by default object is already extended this particular inheritance, and the same way this particular figure also. This figure class also by default is extending from the object class here. Okay, let's observe what are all the information we are having inside this particular object class here. So this is the class we are discussing here, and by default this object class is going to extend it to the all the other classes here. Getting the point? This is important here. And for all the classes, what is a super class here? Object. Okay, and now you can see this is the one constructor we are having here, and static block we already discussed here, and internally, so this is calling one method here. Now understand here get class method. We have a one method called get class. So what it will do? It will try to return the current class information. Getting the point? It will try to return the current class information. Same way hash code method. So whenever we are trying to print the reference variable, this hash code is going to call internally, and it will generate the try to generate the hash code information here. Okay, and here we are having equals method to compare the current object with whatever the object we are passing here. So if I'm giving the information about the what are all the methods we are having inside this particular object class here. Now you can see clone method. What it will do, this particular clone method, it will try to clone the object here. It will try to copy the object. So that we already discussed in the earlier, the basic example box class object we made here, and we come up with the one object declaration, and we so define. Let me show you here. I think here we are having. So if you see, this is I'm creating an object here, and this is the initialization ID, and somewhere box 2, box 3, box 4. Okay. All object we are not cloning it. Okay, cloning is nothing but basically this is an important section. Box 5 is equals to something like box 1. Okay, so this is the cloning section. What we are doing here, box 1 contain the one object here, and the same object I am trying to cloning into this particular box 5 here. So this section will call it as a cloning, and using this particular clone method also we are going to copy the all the object information into the new object here. So we'll see how this particular clone is going to support. And if we observe carefully toString method, so whenever I'm trying to print this particular references here, so for example here I'm trying to print A, and whenever I'm trying to print this particular A, let me print somewhere we are getting it. Okay, so now you can see @ we are getting here. So how this @ is coming here? Now you can see this is an @ is printing. Before the @ what is the information we are having? Get class dot get name. Get class dot get name. It is returning this message. com dot core java 07 and inheritance B. This is the get class dot get name it is returning. And after this, if you see, it is calling internally hash code here. Internally it is calling hash code. So this is the hash code here. This is the hash code. Now what you understand here, whenever we are trying to print the reference of this particular object internally, which method is calling it? This particular toString method is calling. This particular toString method is calling. Okay. So if whenever you are defining any object, you can override this particular toString method and you can define. So what is the message you want to write, or how object we want to construct here. Okay, this is the default way of constructing an object. But sometimes here, this is not required. We can go for the custom toString method and the custom construction of object information. We'll see how this particular toString is going to work. Okay, we'll define the different way of this particular toString information. Okay, so and finally, notify method. The notify methods and to notify all, we'll try to discuss whenever we are discussing about the multi-threading concepts here. And one more, the weight related information also we are going to discuss in our upcoming classes here. Okay, so all the weight and weight, notify and notify all method. We'll discuss multi-threading related example. Okay, and this finalize method is removed from the 9 version. So we don't want to discuss this particular finalize here. Okay, so these are all about the object class information. So object class can contain some method. We'll try to cover up the each and every method one more time whenever we are discussing about the multiple classes example here. Okay, so tomorrow we are going to discuss about the packages and interfaces here. So any questions regarding our today's session? Okay, so if we don't have anything, we'll continue tomorrow. So tomorrow also we are going to discuss one of the important concept, how we can come up with the interfaces and how we can come up with the package section. So once we complete this section here, we'll move on to the one of the important concepts called what we will discuss, exception handling. So once the packages and interfaces completed, we'll move on to the exception handling. We'll come up with multiple exception, how we are going to handle. Okay, so that we are going to discuss once it is completed, packages and interfaces here. We'll continue tomorrow.
Okay, sir. Thank you.
Thank you.